Now this is Graphing Quadratics Part 2, and now we're going to be looking at what's called vertex form. And we call these vertex form because it's easy to see the vertex in the equation. A transformation has been applied. We started with the basic parent function f of x equals x squared, and now we've subtracted 5 inside the function and added 6 outside the function. So that means the graph has shifted 5 to the right and 6 up, making the vertex now, instead of being 0, 0, the vertex is 5, 6. In g of x, we see the same transformation, 5 to the right and 6 up, plus we have a new slope of -2. This just has a slope of 1. So the vertex on this graph is still 5, 6, but that -2 means that the graph is turned upside down, and it is now stretched vertically. So it's going to look thinner and more stretched out. So let's see what else we can figure out about these equations. It's always easy to figure out the y-intercept. To find the y-intercept, we let x equal 0, and if you plug that into the function, f of 0 is equal to 0 minus 5 squared plus 6, which gives me 25 plus 6 is 31. So my x-intercept is 0, 31. Not a terribly helpful point, as it turns out. It's kind of far away from the vertex. If I find the y-intercept of g of x, I'm going to find it's probably going to be even a bigger number. So let's just try that. G of 0 is -2 times 0 minus 5 squared plus 6. That's going to be -2 times 25 plus 6. -50 plus 6 is -44. So that's going to be the point 0, -44. Once again, probably not going to use that so much when I graph. So how do I want to graph that if the y-intercept isn't terribly handy and there's really no easy way to find x-intercepts from this form? This is one where I would start by plotting the vertex and either using the slope or a couple of other points to finish the graph. So let me make this kind of tall because I realize that it's going to be far up there. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Here's my vertex. Now, 0, 31 somewhere way up here somewhere is going to be my y-intercept. So I probably am not going to plot that. So what should I do? Well, I know the point 5, 6. So let's see what happens if I put 6 into the equation. If I put 6 in the equation, I get 6 minus 5 is 1. 1 squared plus 6 is 7. So all it did is move the graph up 1. Well, doesn't that make sense? Over 1, up 1, because I have a slope of 1 here. If I put 2 into the equation, 2 minus 5 is -3. -3 squared. I'm sorry, I don't want to put 2. I want to put 7. I put 6 in. Now I want to put 7 in. So basically I'm doing this. I had the point 5, 6. Then I found the point, put 6 in, and I got 7. And then I put 7 in. Put 7 minus 2. 5 is 2. 2 squared is 4. 4 plus 6 is 10. So notice when I went up 1 in the x direction, I went 1 up in the up 1 in the y direction. If I go 2 in the x direction, it takes me 4 in the y direction. Same pattern as I noticed before. So 2, 3. So I'm at 1, 2. So 2, 4, 6, 8, 10. So now if I go over to 7, I'm up to 10. And I can then do the same thing going backwards. There's my graph. This is not terribly neatly drawn because I don't have a grid, but that's the basic shape of the graph. So start with the vertex, pick a couple of other points near to the vertex, use symmetry to draw the rest of the graph, or use the over 1, up 1, over 2, up 4 pattern. Now, what happens if we have this one? We already know that the vertex is the same, and we already know that it's flipped upside down and it's stretched. So let's start with the point 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Here's that point right here, and I probably should have moved it down a little bit. And if I put in, here's xy, if I put in 5, I get 6. If I put in 6, what happens? So let's look at the equation. I put in 6, this becomes 1. Negative 2 times 1 squared is still negative 2. Negative 2 plus 6 is 4. So notice I went up 1x, down 2. Well, that makes sense because whatever the very next point is always going to reflect this number here. So I'm going to go over 1, down 2. I'll do that on both sides. Then if I go over 2, let's put a 7 in here. 7 minus 5 is 2. 2 squared is 4. So there's that pattern of 1 and 4 again. 4 times negative 2 is negative 8. Negative 8 plus 6 is negative 2. So I'm down to negative 2 now. So notice here, up 1, down 2. Up 2, down 8. Same pattern I noticed before. Let's see, I think I actually plotted this one a little bit too far over. There we go. Taller, it's upside down and it's skinnier than our other graph. Okay. Well, it's hard to know that it's skinnier because I made the tick marks a little different, but it is stretched in the y direction. So that is how you graph something that's in vertex form. Number 1, find the vertex using the shifting pattern that we noticed with transformation. Number 2, plot 2 additional points to the right of the vertex using the next 2 x values, either using a table or using the pattern involving the slope, and then draw the other side using symmetry.